Hello everyone, so welcome to my channel. So now it's turn of the second question. Basically this is not a second, this is the fourth question of the contest. But let us start with this question. So here in this question, basically this question is of DP. But the thing is that in this video, I'll just explain you about the bottom-up DP manner, that how we get the idea that how that bottom-up DP would be there. And for the recursive and then memoized and then bottom-up DP, about that I'll make another video because that will be a 30-minute video. So basically I just want to end up in less than 15 minutes so that you get overview of that how we are required to do this question. So let's get to it. So here you are given a string S consisting of lowercase letters and integer k. We call a string T ideal. So for that conditions are that T is a subsequence of string S, that is the thing, and the absolute difference in the alphabet order of every two adjacent letters in T is less than or equal to k. So the thing here is that somehow you can see that it is longest ideal subsequence. Could we call a question of DP which was somehow similar to this? It was longest increasing sequence, right? So here are the increasing, they have put it as ideal. So there is a little bit modification in the longest increasing subsequence with this. So here what they mean by ideal is that the particular subsequence should be there, which should be part of the string S. But the second thing which makes that particular subsequence as ideal is that the difference should be less than or equal to k. So here's the thing we are required to think, and according to that only we are required to code this question, that the difference should be less than or it should be equal to k. Means not only just equal to k, but it could be less than k also. So here comes the part that we are required to think this question of doing LIS, but in this LIS also we are required to give a particular range in which we are required to go ahead with the solution. So that's the thing which we are required to do here. So at the end we are required to return the length of the longest ideal string. So this is the thing which we would be doing here. Means we are required to return the longest and it should be ideal string, and that ideal string is basically the longest subsequence where this particular condition fits in, that is the difference of each adjacent characters should be less than or equal to k. So this is whole about this question. And now one more note is given to us that the alphabet order is not cyclic. So whenever we are calculating the difference part, so in that we need to keep in mind that A and Z, if anywhere we got them, means A minus Z or Z minus A, then its difference would be 25, not 1. Because it is not cyclic difference, it is just a straightforward linear difference. So that's why this also is a thing which we are required to keep in mind. But this makes our question much more easier. So that's a good thing for us. Now let us see first example. So here we are given with A, C, F, G, D, D, right? So we can see that A and C, so both of them, and in the subsequence we know that it is a string that can be derived from another string by deleting some or no character. So it could be having some adjacent characters also, and it might not be having some adjacent character. Basically, if we choose this A, C, then it is a subsequence, we can consider this, but even if we consider AF, then that is also a subsequence. And even this ACF is also a subsequence, and even the whole string would itself be a subsequence of the whole string. That is also true. So that's the thing. So here what we are required to do is this AC which is there. So for this AC, the thing is that we are now required to check that what is the difference between A and C. So it's directly that C is 3 and A is 1, right? So C minus 1 is 2. So our K is also 2. So this satisfies the condition. So we'll put this particular in our data structure and increment the length, that now we got 2 length to be returned as the longest to be returned as a subsequence, not the longest one. longest we need to check. Then we are given with f. So if we add this f to our subsequence, then what would be the criteria? See, C and F, if we do the difference, then it is greater than K, right? So that's why this can't be included. So now if we next check D, right? And then if we check D, right? So G is also not the one which will satisfy the condition. So it will again be discarded. And then if we check D, so B and C difference is 1, right? Which is less than K. So it will be added into a subsequence. So now A, C and this D are added to a subsequence with the length 3. Now comes the part D. So if we do the difference of D and D, what our difference would be? That would be 4 minus 2, that is 2, right? So this D would be also included to our subsequence. So this is a thing which we would be doing, and at the end we'll get our maximum length would be 4 for the same. So that's why our subsequence length here is now 4. And then we'll start with C, and now in the C we'll go ahead with all other, and we know that we had already calculated with the same, so we'll get now 3. And then we'll go ahead with F, and this in this F then we'll check for G, F and G, right? 1, so G would be included, but G and D, they don't have the difference less than or equal to K, so B would be discarded. Then B and D would be discarded, right? So D would be there. Then D, E, F, G. Then again, we required to discard this D. So now we got a subsequence which is of length 2. So earlier we were having a subsequence of 4, right? So now this new would be discarded because we require the maximum, not the minimum. So like this, we'll go ahead with G and then with B and then D. So at the end, we got our answer that we are having a longest ideal subsequence which is of the length 4. And this is how we are required to do this question, means iterate over the string, and this is somehow similar to that longest increasing subsequence only. That is iterating over the string and finding out all the possible answers which could be there, and then comparing them, that out of them which one is the longest. So that is the thing which we would be doing here. So now comes the part that how we are required to code this question. So before coding, let me show you about the few pointers which would be required. So what we are doing is we are required to check for less than or equal to K, right? That I already explained you this. And then the thing is that dp of C, that is because we would be directly going with bottom up solution. So the thing is that dp of C would be that particular point at which we would be checking for the length of the longest ideal subsequence ending with the character C. Means till now whatever character C is there, till that we will be checking for all the characters. Are the difference equal to or less than K or not? That is the thing which we will be checking here. We can check I minus K alphabet, thus all those with C minus 0 minus K difference would be there, will be considered, and we want all of that. So that is the thing which we are doing here. So now comes the part. Now C can be the next character for the string ending from I minus K to I plus K, as earlier we figured out till I minus K means till present character. So the thing is that this C, which earlier was the last character, now this could be considered as the first character also of another subsequence, right? So that's why we are required to define a range which would be between this. So this is the whole crux of this question, that how we were required to define a range for the same question. And now we need to figure out present character as backward character of any other character. So this is the thing which we would be doing here, and this is how we would be coding this question. And now J could be from I minus K to I plus K, right? And we know that I could be, right, whose SKY code is 122, right? So k at max and k at max could be 25 as per the constraint which are given to us. So that's why j could be I plus k, that is 125 plus 25, which gonna be equal to 147 and round it off to 150. So according to this, we are required to take the range of our DPN. So these are the few pointers which you are required to keep in mind before coding the solution. So this was all, and before showing you the code that how we are required to code this particular question, so you should think about it, that how we are required to code, so that you could easily able to do all this during a time of interview. So you can even pause this video and code it, and then you can check the code, that what the code is here, right? So yeah, and from the interview only, as lot of students were asking me about a particular course, that they require a course which is well structured, gives them one-on-one mentorship and live doubt solving and so on. So for that, you could simply check out the Newton School, whose description who would be given in the description of this video. Means every link and so on information would be there in the description of this video. So you could check out there. And the best thing which I have figured out about Newton School is that you don't need to pay anything beforehand. You are just required to pay after you are being placed from because of the Newton School. Because Newton School would provide you with a placement of 4 lakhs to 40 lakhs, and that is the thing. And for that purpose, means after your placement only, when you would be enrolled in this course and when you are get placed, then after that you can pay the fee, and before that you are not required. So yeah, if you are interested, you can, it's your choice. And now comes the part that how you are required to code this particular question. So here's the thing. So we are required to take a DP of 150 size, right? And I've already told you that why 150 size, that's the thing, and the result equals to 0. Now what you are required to do, you are required to check each and every character from the string which is being given to us, and from that only then you are required to check that if this I which is there, because it would be A itself, means A alphabet itself would be there, right? So now the thing is that because this is the A alphabet itself, so when we would be doing I minus K and when we'll be doing I plus K, so it will check for the ASCII codes only, right? Here I had written for the, when we convert that C minus with the 0 is means when we convert it in that form that it gets the value as 3. So in that context I was doing, but here it will convert it to its ASCII code itself, right? So here the range would be this, and now here we are required to check what maximum value the CP of I could obtain at this particular moment. So that's what we are doing here. And now next comes the part that for updating our DP of I, then for every character that ends with character J can be used to append this character I with the maximum 1 plus DP of J length, and this 1 plus we have directly done here, not at this step, so that there is not much confusion. So that's why we have done here itself, and here it will directly update that whatsoever value was there at the position of J. And now at the end we need to update our result also, and as we have appended one character now, right? So that's why at this particular point what we will be doing is we'll increment with the same, and then we'll check that out of them who is the maximum, because earlier in the example we were checking that out of them which one is the maximum, right? And we figured out that 4 which was earlier taken, that was the maximum one. So that's why we are putting this maximum, and if the previous node was the maximum then it would be there, else the newly one would be there. So this is the step for increasing the length which we are required to update after getting this particular step, and at the end we'll return our result. So this was all for this particular. And the time complexity in the space complexity. So the time complexity for the same would be order of n, and the space complexity would be order of 150, because we are taking this DP of 150 size, right? And any other space we are not taking. So that's why here even the space complexity is of this constant time, and the time complexity order of n, because we are traversing this particular string once, and that's all. So this was all for this particular question. If you have any doubt, you could comment that down. And yeah, thank you.